let's get started. Obviously, there's the agenda. Can you skip through, Jay? So I'll kick the introductions. So my name is Jack Thompson. I'm one of the account managers at Visual, based in the sunny Staffordshire. I'm joined by my colleague, Joe Tompkinson, today.
Hi, I'm Joe Tompkinson, one of the software developers here at Visual, and I'll be guiding you through the majority of today's webcast.
Great. So just quickly, for the ones who don't know us, I just wanted to share this infographic about what we're currently doing. These 4 pillars perfectly sum up the work we've been doing recently, so just wanted to just briefly walk you through them. So firstly, the consulting side of the business. So this splits into 2 halves. We have business advisory, which fits into planning side. This is aimed at helping organizations set strategy, review their strategies, how can technology help, and so forth. This then leads on to the actual implementation side. The managed services is around monitoring. We do all the standard stuff like patching, security, break fix. But where the really cool stuff comes in around the optimization. So this is where we help organizations track their costs on platforms like Office 365, Azure, and make recommendations to get them to the least cost possible. We also hope to make some cost savings across the way, and I've done so with lots of organizations we work with. Skills is all around developing and adopting technology. So we can help with apprentices and the wider education to technical and end user teams on all things Microsoft. And lastly, solutions. So some key solutions aimed at safeguarding children and vulnerable adults. NIMOS is currently being used in the South Yorkshire region to help with child exploitation and passing information securely. Separately, we have a customer experience application aimed at connecting customers with organisations more personally. In short, that's Visual, and that's my introduction slide over. So now I'll hand over to Joe to talk through all things around AI, automation, and machine learning.
Well, hello everyone. Thank you for coming in to listen to me go through this. It's a big topic, the things that we're going to talk about today, and in an ideal world, you could easily have days workshops on each component of this, whether that's DevOps, automation, AI, or machine learning. So I'm just going to give you a brief overview of what we're going to go through and a rough idea of the order. We're going to jump in firstly to have a look at DevOps as a methodology, what it means to businesses, and how it's a movement to kind of create a better, more streamlined development to production process. We're going to have a quick look about how that can be made more efficient through the use of automation within the DevOps cycle. We're going to then have a little look about how automation within your own internal business processes can be adopted and utilized. And we'll talk a little bit about something called Microsoft Flow for that. After that, we're going to look at something called AI Ops, which we'll go into a little bit more detail, which is a component that sits on top of the DevOps process and is very much a buzzword of the last sort of 12 months or so, and it's quite interesting. And then we're going to finish off with a little bit of look about how AI and cognitive processes are being used within different industries, and some of the demonstrations and proof of concepts that Visual's done in the last sort of 12 months for various clients, and how that works, and the kind of cognitive technologies that sits on top of. With that in mind, we will jump into DevOps. Now, DevOps is something that a lot of people will be familiar with as a term, at least, and if you Google it, you'll see a lot of different descriptions of it, and I went with good old Wiki for our demonstration here. This one is marking it as a software development methodology, which is exactly what it is. Combines both the development and development and operations side of applications lifecycle. And the goal is to essentially make that process more efficient and streamlined. And we'll go into a little more detail about how that can be done. DevOps is a fundamental process methodology within any business that's got a line of business application that's critical to either their users for either internal or external use. And we're going to look a little bit about how that's done. So DevOps as a cycle looks to engage from developing a solution, developing functionality or code, supplying that into the lifecycle and chain, and that going from development all the way to testing, to deployment and monitoring and maintenance. And it's essentially an infinity sign is the way that they usually mark this in the cycle diagrams. And the idea is that each of these sections plays a role. They can be made out of different tool sets. Here at Visual, we use primarily Microsoft Azure-based toolkits for DevOps. We use Azure DevOps as our source control repository. We use that for continuous integration and deployment, which we'll talk about in a moment. And the idea is that as a methodology, it's bringing that process into line of sight, not just for the individuals that work on these applications, but also to business stakeholders that require visibility into how these applications function, how they get to market, what problems and blockers are currently impeding the speed at which you can release fixes or new functionality. Again, both internal use applications and external use applications. One of the ideas is that it gives an informed visibility of the process. As I said, we can track indicators of the speed that defects can be processed. And you'll see a lot of talk about MTTR, so mean time to resolution, the time it takes to fix a problem when you're looking through maintenance or when you're at that maintenance section in the DevOps cycle. The general concept is that it's designed to, over time, decrease the amount of bugs you may get in a production release, decrease the time it takes to actually create and push out to production that new functionality. And one of the ways that we do that in DevOps is through automation. Automation is there to try and restrict the requirement for manual processing by members of your team that work on this kind of software. As we know, manual processing is something that leads to potential human error, or there's an inherent time requirement for someone to action something, from receiving notification of needing to deploy to another environment to actually deploying it. Whereas automation in DevOps looks to take out that manual process and essentially automate it for you. One of the ways that this does it in an application DevOps cycle is automating builds. So a developer, for example, someone like myself, would pick up today's tasks, whether that be a series of bug fixes or work items against a new piece of functionality that we want to roll into a new release. I'll start to build out that code against that work item or bug. And then when it comes time to check that fix in or addition in, I do that through my normal IDE, which is Visual Studio for myself, but other people can use different IDEs, which is really just the UI we use to code in. Once I check that in, I can use automation to attempt to build that. And that's all done in the cloud. We use Azure DevOps automated builds. So as soon as the check-in is pushed to source control, that build is then triggered automatically. It attempts to compile that code. If the build fails during compilation time, it will then notify me of that. And I'll know that something that I've checked in isn't quite right, which, as most people in development know, we like to say doesn't happen at all, but it does happen. It's quite common. But the concept here is that the time from pushing that code in to knowing that something's not right is reduced significantly. So the time it takes you then to rectify or remediate that problem and re-push that code for a new build is decreased, which is the concept of having your automated builds. And that's just for compilation, of actually making sure the code runs. We then go into things like automated testing, which are quite interesting. They allow you to run a series of tests against your software, against your website, against whatever it is you've put out there, and they will predetermine. You will predetermine what you're expecting that software or that website to do, and you'll pass or fail it. You'll assert a pass or a fail, and those will also get triggered. So if I was to push up a build to one of our websites, and there's a submission form that's expecting a certain a certain figure, and normally we check for that. So say we're taking a phone number and we look to ensure that it's 11 characters and it's of a certain type. And I push some code up to add some additional functionality to handle country codes, for example, and for whatever reason I break the validation. The unit test that's being automatically ran against that will pick up that that's no longer working, and it will become a regression problem. And as a developer, I will get notified of that. It'll tell me what I've done wrong, or what test it's failing on. It will give me a good idea of where I need to look in my code to then fix that. And then once automating testing has passed, we then go through a pipeline of automated deployment. So in most environments where you've got a business critical application, you have 3 environments at the very least, one being your development environment, where you'll do a lot of your code work and testing. You'll do UAT, which is an environment that mimics production more realistically. And again, testing is then performed on that, and then you'll go to production. And with automated deployment, we can actually have these as gated releases. So we can automatically release to development. A tester then has to give approval to release that code to UAT. And then the testers that look at the UAT environment and the way that the code functions, along with a key business stakeholder, would have to approve a release to production. So it allows to mitigate any human error on code getting somewhere that it shouldn't do. Now I set up a little sort of demonstration for this. So I'm going to pop out of the presentation very briefly. Assuming I've got everything loaded up, we're going to have a quick look at just a little bit of a build screen for a bot framework I'm working on. We'll talk a little bit about bot frameworks later on. Now you'll see here that what this conveys is a series of builds, whether they've passed or whether they've been paused or failed. And the way these essentially work is, at least in this instance, is when I check code into this, it'll perform a build, but I can also enqueue a build as well. So you might get a tester that actually wants to build a previous version, for example. So they might want to enqueue it. They'd start that process. This is all documented in the history. So this whole platform of DevOps generates a lot of data. If we go in and have a quick look at this, the way this works is it's ran on an agent in the cloud that takes all the code that we've put in and starts to process it and compile it and ensure that it runs as a body of software. It does take a while, granted, in some cases, and it depends how complex the code is and what it's sat on. But instead of me having to just publish code directly in, this will ensure that it has been checked, that it compiles correctly. And I'm just wondering if we'll wait for this. It takes about a minute or two. We probably won't wait for the whole thing, but once that's completed, we'll pop back in and I'll show you essentially how releases work in real time. But we'll just pop to releases at the moment while that build's going off. Now, releases are essentially your gated deployment. So these form part of your continuous deployment processes within Azure DevOps or within your DevOps cycle. Every time you build one of these pipelines, you can set how many stages there are. Now, I've just done a simple one that has a gated release to our development environment, just to show you how that process works. As soon as a build has been completed, it will create a release automatically and email the approver, which in this instance is myself, who would then come in via a link in the email and essentially approve one of these releases. But I can also manually create these releases. I'll just pop one through so I can show you. So release 5 gets queued, and this is where it then starts to look for approval once it's ensured that it's built. And you'll see there it says pending approval. What that will have done is sent myself an email, and when I click a link in that email, it'll push me through to this page. As an approver, all I need to do is click approve, add a comment, and if I want to make a comment on it, so this is expected, which is always nice, and you can approve or reject, just depending on what your current requirements are within your DevOps process. Once that's done, it starts to run that deployment on again, another agent sat in the Azure cloud. This then deploys it to a predetermined app service sat in Azure, and once that's completed, everyone that needs to know about it gets sent an email. and we can then see that code running in development. So the idea of automation here is just to make things really quick, really easy, really simple. It's to streamline a process that a few years ago used to be potentially quite complex, quite convoluted, and to take out these tedious manual operations where we're doing it, which is incredibly important when you've got an application that drives business or drives internal use where a lot of users rely on it. It's key to ensure that these are released quickly and without too much of a problem, which is what we all want to avoid. That will take some time to process, so we'll pop on back to the presentation. Just bear with me. An automation within the DevOps cycle isn't the end. We can look at your internal business processes. I know that some companies, some businesses and organizations do annual internal reviews of their processes. Where is it where my employees are having to spend the most time? Is that something that we need them to do manually? Can we automate it? If we can automate it, how easy is that to do? And how can we put it in place in the way that's going to be meaningful? So again, you may or may not have heard, but Microsoft is starting to collate what they're calling their sort of Power Platform, which includes Power Apps, Power BI, and Microsoft Flow as a way of automating various processes, either through semi-autonomous triggers or automatic triggers. The idea of this is that you can reduce the time it requires employees to do something, make them more efficient. There's no point doing a task you have to repeat over and over again manually if it can be automated. One of the beautiful things about Microsoft Flow is that it's already got hundreds of connectors into various different systems in the cloud, whether that's SharePoint or Azure DevOps or your email account, 365, almost everything is interconnected into Microsoft Flow. Even RSS feeds, loads of different ways that you can do this. They also accept things like HTTP triggers that can be triggered from websites that you may expose publicly to run automated processes in the background without having to know much in the way of development really to put these together. So we're going to take a quick look at how these flows work. So I put together a couple of examples. They're nothing particularly special. They're just some ideas of how this works. One of the things that I was looking at just to showcase a couple of things was the ability for a Microsoft Flow to be triggered to search my OneDrive for documents that match a specific name. So I've pre-done this, but I was going to type it in for you, so it looked all fancy. But if I was to click this from PowerPoint, it will fire off a Microsoft Flow that will search my OneDrive for any document called document. Ironically enough. What it'll then do is it'll grab a shareable link for that document and email it to me so that I can then forward that on. The kind of use cases for this are things like if you've got HR or personnel and they need to send out contracts and they're having to search through OneDrive themselves continuously, well, you can build a quick little platform that utilizes Microsoft Flow to do that, to prepare all the things that they need to send out and send it out for them. In this instance, the email is to myself, but it could quite as easily be externally. You can pass through an email address or recipients if there are more than one, and Microsoft Flow will email that on your behalf. And you can set up the styling, the body and text and subject, and it's a good way of automating internal and external correspondence that happens regularly. I'm hoping I can just show this. I'm going to have to pop out of the presentation because that will run the flow that will search against my OneDrive, and I do apologize, I haven't got this signed in, so we'll just sign into this. I'll try and do this quite quickly. Whoops. So you'll see there that we have an email from PowerPoint that basically gives me the share link. It's searched my OneDrive and it's brought through the document and the share link for it. It's done that pretty quickly and without too much hassle. So it's just an example of how quickly Flow can work to automate these processes. I also set up one for failed builds in Azure. If a build fails in Azure DevOps, I can trigger it to automatically store some information about that failed build in a SQL table, which I might want to use for predictive modeling at a later date to tell me a bit more about why it failed, which I find quite interesting. I could probably queue up a failed build, but we might do that later, so I probably won't show you this one now, but because there's currently a build processing. But this is just the idea that these automation processes aren't just for your DevOps cycle. They're absolutely for internal business processes as well. And they play a fundamental role in streamlining your operations on a daily basis. And that brings us into the next stage of this. So we've looked at DevOps and we've looked at how that process can be augmented by automation. These are all fairly static processes in a way. They have a singular purpose, they process a singular function, they either build, they test, they deploy. But one of the interesting things that's coming up and has certainly been mentioned quite a few times in the last 12 months or so is AI ops. And as you can see on the slide, it was formerly called algorithmic IT operations, and now forms part of artificial intelligence for IT operations. And these are things related to how we can augment that DevOps cycle and really make it meaningful for the people involved. So the Azure DevOps platform drives, just by its very nature, the collection of a large amount of data, whether that's the information of check-in history, the code that's being checked into the solution every time a developer pushes new code up. It records builds that fail, builds that pass. It records loads of different bits of information around bug remediation. For example, when you check in a remediated piece of code against a bug, Azure DevOps records that change set, that body of code you've pushed in, is for that particular bug, and that's important because the language that's used in that bug will come back to be processed later on. So artificial intelligence in this looks at how we can leverage that data, that big data that sits below the DevOps process, and we can start to do some things that are really clever with it. So we've got all this information. We've got all this information around all these different kinds of bugs within the software that have been remediated in the past, and every now and then you'll get replications where bugs are very similar. There's a very similar problem in one element of the application that's occurred in another. And as that data starts to get stored within Azure DevOps, you start to then get the basis of being able to do some really interesting modeling with that, with machine learning. So one of the things that you would look to do is go, well, we've just had a failed build. The code and bug already match something that we've seen fixed before. Now, bear in mind that this will take the bug text and it will take the fix code and it can then suggest that to you as a fix for a problem that's arisen. And this sort of process can be automated to then use machine learning to give you some really meaningful information about the data stored in Azure DevOps. So it uses anomaly detection to look at code that's checked in and determine where something doesn't fit the standard pattern. Now, you could even do that to enforce standards, although there are mechanisms for that already built into the process. You could use that to essentially detect anomalies where it's matched a pattern that we already know has failed for a check-in, we already know has caused a problem with the testing. Something that's already in the past been incidentally released to production that's had to be remediated quite quickly. And this doesn't just sit around the code either. Azure offer quite a lot of fairly robust and resilient work around predictive maintenance solutions. And we'll come into a bit more about that in a moment. We're just going to pop through and talk a little bit about how pattern detection works. So pattern detection is quite an interesting one, and one of the things as a developer that I've certainly realized in the last sort of few months is that Microsoft is certainly putting a lot of time into building these services out for us to use straight away, as is a lot of the big IT companies, to be fair. One of the really interesting things that they put out there for us to use as part of the DevOps cycle, especially as developers, is something called IntelliCode. Now, the way that this works is it's an extension for Visual Studio that developers code in, and it applies essentially a a pattern predictive model against the code base itself, so that when a developer or a team member is going through and writing code, it attempts to give them the most likely predictive next property they might need. And I've been using it myself for the last couple of months, and I can tell you it's actually incredibly accurate. And it's just one way where pattern detection fits into this DevOps cycle, because we're starting to leverage these processes not just through automation, but through machine learning and AI, augmenting each of these steps by adding in the power of predictive analysis and pattern detection. And with all that data there that we've got readily available to us just through the very nature of this process, this becomes a very real possibility. When you've got anything that goes through a DevOps cycle, you're inherently generating this kind of big data. So you don't have to worry about trying to collate it yourself. It's already there, which is fantastic. And pattern detection tries to, through machine learning, pick out accurately very familiar patterns, what looks right, what doesn't look right, what looks to be something that we've realized is in fact a real problem in our code base. And then it processes that and sends that information to the developer. The idea is to speed up the kind of remediation process that they have to go through on a daily basis. It's fantastic. We're going to look at predictive maintenance solutions now. These are a beast unto themselves, if I'm honest. The way these work, and I'm really only going to talk about the Microsoft Azure predictive maintenance solutions, as they're probably some of the most robust that I've seen, look to analyze services in the cloud. So if you've got app services, websites, SQL databases, anything that you can run in Azure, they generate a series of data around failures. And the way that predictive maintenance works is that over a period of time, and these do have a learning period, that is something that has to be said, where they determine what has worked, what hasn't worked, what is going to cause a failure, what could cause a failure. Once that's all been trained over a period of training time, it then starts to build up a really interesting network of observations around existing services or assets. And the way that works essentially is that it looks at things like load balancing, peak usage times, the regions that connections are coming from, what regions generate the most usage or are the most likely to cause a heavier load on a service. And it uses this data to match pre-existing models. You know, is this particular scenario that this service is experiencing similar to one that we know causes a failure? If so, we're going to alert those that need to know about it, and this is where operations come in. Operations then get notified that an asset is under stress. Now, there are these notifications anyway. For the most part, a lot of these assets are horizontally scaled, so we give them a little bit more processing power. They can handle connections in a little bit better. But what we're looking for here is these critical points of failure. And that's the idea behind predictive maintenance solutions, is that they're driven by AI to tell you when an asset is genuinely going to fail, because that's what you don't want. There can be as many redundancies in place as you like, but really if you can know ahead of time that something's going to happen, you can put plans in place. And as that starts to grow within business, you can start to have predetermined plans for each event. And it just allows you to be a lot more prepared about these sort of things. And it is very important because, again, the Azure platform and the cloud platform generates a lot of data. There's a lot of big data to be analyzed. If it's used in the correct way, it can provide fantastically intuitive solutions based on machine learning. I think one of the solutions that is already pre-built that you can actually go and test today, that was produced by Microsoft, and they've even got a GitHub for this, is something called their Predictive Maintenance Solution Accelerator. You might have to Google that, and it will come up with an example of how Microsoft have put together this kind of solution in a testable, demonstratable way. It's quite in depth, otherwise I would showcase it for you today, and certainly happy to talk around it at a later time. But it tells you how that sits together in your Azure environment and what components need to be put in place to allow predictive maintenance to function. What you need to hook it into to get it to notify the correct individuals that the problem is about to happen. And that's what forms AI ops really. It is integrating artificial intelligence and machine learning into your DevOps process. And it does sit in there. Anywhere that generates big data can be used to leverage machine learning. It's really just finding the right ways to use it, how it's really going to benefit business, how it's really going to benefit process and efficiency. And that's the key. There are quite a few people that are looking at doing these sort of things at the moment in industry. It's something, again, that we can perhaps talk about off the presentation. But it's certainly a really interesting concept, and there are some quite interesting success stories, especially ones that Microsoft have put out there for people to look at. And if it's something that interests you, you should certainly dig a little bit deeper into it, because it's mind-baffling how that actually works to a certain extent. And that concludes really what I want to say about artificial intelligent operations and how that fits into DevOps. I kind of want to move on and take a little bit of a closer look about how AI and machine learning can fit into the industry in a wider way, in a way that sits outside of the DevOps process around your applications, that perhaps would form applications of their own. So we're going to have a quick look at AI in industry. I think everyone has encountered some form of AI over the last 3 months, whether that's shopping for a phone contract and getting an advisor pop-up asking if you want to help. These are very basic examples, and I'm going to go through some more in-depth examples of this. But chatbots are really, really prevalent right now because they're 24/7 resilient bits of application software that allow you to be more connected with your users, whether they be external clients or internal business users. They leverage a pre-existing platform of cognitive services, and they can utilize natural language processing to be more conversational, less robot-like. They can handle live language translations now, which is absolutely phenomenal if you're in a situation that's required. And they can perform simple things like scoring, which is how sentiment analytics works. And all these things by themselves are interesting, but not necessarily useful by themselves. It's how they are incorporated into a piece of work is what gives it meaning. So I'm going to kind of go through a couple of examples with you now of different industries and how they're using this kind of technology right now. So if we look at, for example, the finance and banking industry, what they're doing right now with AI and cognitive platforms are incorporating these sort of deep learning technologies to analyze patterns of suspicious behavior and potential fraud. One of the real life examples is PayPal. This year, or I think it might have been last year, they actually reduced the annual cost of business of fraud down to 0.5% through employing these kinds of deep learning systems. They analyzed the transactions in real time to look out for anomalies using anomaly detection. And that sort of thing is really important. If you get a phone call from the bank saying they're worried about items on your bill, that's not because a person's looked at your account and thought, why are they buying that second pair of shoes, or why have they bought a hat from Tenerife. It's machine learning algorithms that are transacting through these items on a daily basis, incredibly quickly, I must add, just because the sheer volume of data that goes through them. We can look at healthcare, and one of the best examples I can think of is Microsoft's Hanover project, which is using machine learning and natural language processing to make predictions about the most effective cancer treatments for patients, and that's on an individual basis. It uses that particular person's medical history to determine what's going to be the best treatment plan for them, which is fantastic. One of the obvious ones which I've mentioned is in the retail sector. It's probably one of the biggest sectors that it uses artificial intelligence in. Conversation intelligence software is incredibly useful and important to that industry, where they can have these conversational bots processing 24/7, interacting with their customers, helping reduce workload from their support lines, helping process transactions in a way, or contractual work orders in a way that doesn't require manual intervention. And this is a really big thing. in the industry. A lot of people are trying to automate processes, not just for feeding back from a knowledge base of how can I help you, what do you need to see, but actually them being more functional. Someone wants to upgrade a phone contract, well, great, you don't need to speak to anyone, we can do that. We'll do that all through automation and AI. And that's a really big thing. Recommendation engines within that industry, for example, are massive. You just have to look at the likes of Amazon, for example, have been using recommendation engines for a good few years, to be fair. The intelligence it has improved, certainly, over the last few years. But you can see things like that, where one item has a relationship to many, uses these machine learning algorithms to understand more about your shopping habits and how it can present you with the most likely purchases that you would want to commit to. We can look at higher education, for example, and there's I was reading recently about a university in America, Oregon State. They had a problem where they had a couple of courses that had a really high attrition rate. Students were finding it very difficult, and they were dropping out quite frequently. And they employed adaptive learning technologies through AI to determine better ways to help their students handle these kind of things, which is fascinating how that works. One of the most interesting that I certainly looked at recently was energy and utilities. So energy companies both in the UK and abroad. One of the most sort of popular implementations of machine learning was looking at intelligent energy forecasts. They used data analytics for managing intermittent renewable energy. So in places like Iceland, for example, rely quite heavily on, or I believe entirely, correct me if I'm wrong, powered by thermal energy production. These sort of algorithms and analysis are used to detect whether there would be any shortcomings in power in that system. And again, it's another US example, but it was one that was certainly quite interesting. It was the Department of Energy, SLAC's National Accelerator Laboratory in the US, were looking to use or deploy something called autonomous grids. So if there was a power outage in a particular section, it could be automatically routed, and it could try and predict the best way to channel that power and circumvent an outage, which is a really interesting use of AI. So this is just an example of how artificial intelligence can be really readily deployed to almost any industry, as long as there's a credible use case for it, and there is. In almost every industry, there's a reason to use it in one way or another. And one of the things that certainly I've worked with quite a lot is natural language processing. Now, I leverage a Microsoft service called LUI, which stands for Language Understanding and Interactive Services. And this fits into the more conversational aspect of AI. It allows you to handle conversational in a tactful way and a meaningful way in terms of interpreting the user's intent. And I'll go through a little bit with you about how this actually works in some of the demos, which we're going to be leading into in a moment. And one of the things that's really interesting as a developer especially is that these kinds of services are now offered as a cognitive platform, a collection of services that can be easily consumed by an application. One of the things that we work on over here is Microsoft's bot framework that sits on top of these services and builds out these conversational AIs, these bots that people would interact with. I'm very happy to be able to show you on the next slide a development preview that we were working on recently around operational data. But the way that the bot framework works, for example, is through what they're called dialogues, which are essentially compartmentalized trails of conversation. They're flows, essentially. Processing through conversation with a user in a predetermined way, but they can also be dynamic, because we wouldn't just set them on one dialogue path from hello, how are you, to great, I've submitted that order for you. We would leverage LUI for that, so that we could mix and match between dialogues that best fit that user's response, whether that's they've just said hello and we want to process that in a particular way, or they've asked about a specific service or a specific item and we want to talk about it in a different way. We end up building multiple dialogues to handle those situations. And the way that the bot framework, for example, kind of is utilized is it sits on top of all of these. It leverages these services to do this, to provide this sort of ability. And we can build it in a way that it gets added to. It's really easy to incorporate further dialogues as we go along. So you can start from a very small proof of concept all the way up to a fully fledged chat AI for internal or external use. And obviously, by its very nature, it again drives a lot of big data. Conversations and transcripts can be recorded for analysis at a later date. They can be used in sales environments, for example, to determine the reaction of the customer. Are they happy with the service that they're getting? And we use that through sentiment analytics to determine that. And these all feed into a model of metric creation and reporting, so that on the back end of the bot framework you can see exactly how it's doing. It helps you train it to better fit the users that you supply. It can help you pick out the questions that are most popular and when were they most popular. When should you be perhaps pushing a particular item, for example, or service? And they're incredibly powerful. So I'm going to just quickly show you, and I realized that this is a video and you won't be able to hear the sound on this. I'm going to talk over it and I'm just going to start it. But what we did here was we worked on a proof of concept, essentially, and it was an operational response bot that had the ability to use speech to text. And this is built from Louis as a cognitive service. The bot framework sat in Azure to handle the incoming responses, and this is actually built on an Android client to handle the user's input. We leverage, in this instance, Google Voice at a hardware level to translate the speech to text, because it can be quite easily catered to understand the user's regional dialect and learn from it as well. But not only that, it also allows some additional transparency. In an environment where it might be a user in the public, they can have these transcripts recorded to their own Google account. So they have they've got a recording of what they've just said. What you'll see on this front screen at the moment is something called an adaptive card. This is a way that we display rich, dynamic content in a bot framework situation. In this instance, it's used for an introduction. Once a conversation has started, this is sent to the user just to explain a bit about what they've connected into and to supply them with action links that you just saw scrolling along the bottom. These action links can farm out to websites or other data as you see fit, and you don't have to have them at all. They can do loads of different things. They're quite robust in a way that they can be used for almost anything, especially from a user point of view, to give them really streamlined experiences. Now, one of the primary functions of this proof of concept bot framework was to take in a license plate number and generate a meaningful response by running that against a database. And you can see in the video that I've just processed a speech-to-text voice, and I've asked it to run a license plate number, and I've given it a license plate number. What that's actually done in this instance is it's come back and it's gone, well, I realize that you want to run a license plate number, and I've managed to detect the license plate number from that single sentence, so I can process this. Now, DY16YHT wasn't in the dummy database, so quite correctly, this returned with a dialogue prompt, is what we call it, saying, apologize if you've not been able to find it, and asking them to provide it again in case they've made a mistake. Now, with this kind of thing, we realized that it is possible for you to make a mistake on single character diction, so DY16YHT. It does depend quite a lot on your regional dialect, your accent, how the framework understands what you're saying. So what we wanted to do, because we understood that this might be used in an operational sense, is train Louis to understand the NATO phonetic alphabet used by police forces in the UK, for example. And that was something that Louis is capable of picking out of a sentence. And I'm going to bring this up in a moment, hopefully, to show you kind of how that actually works. In the video, you'll just see me passing through the license plate number, and it'll correctly respond with some information. Now, don't worry, the information is dummy data. Jeffrey Luton doesn't exist, and I'm not entirely sure where Scarsdale Road is. But the concept is that it can prompt you or re-prompt you if something's not quite right. It can understand multiple bits of information from a single sentence, very similar to the way that Alexa works, for example, or OK Google, Google Home, things like that. And these are all built from natural language processing, and it's extremely powerful. It's extremely relevant in a lot of industries to build something that can handle this kind of sort of dialogue with customers. Now I'm just going to show you now on this the phonetic response, just so you can see it. And again, the way that this actually works is it picks out the intent from the word plate number. Now it ignores the one at the beginning just because it doesn't need to know why I've done that. It just needs to know that my intent is to run a plate number again. And then what Louis does is it looks at a list of phonetic alphabet words and determines whether one is within that sentence. Now, as a developer, what we've done here is we know the user wants to run a license plate number, so we make an assertion that if there is a phonetic alphabet within that sentence relating to a license plate number, that it is in fact a license plate number that they're trying to provide us, which means that we can isolate that scenario and apply a certain algorithm to it to then turn that phonetic alphabet into a working license plate number to run against a database. Now in that dummy database, it is recorded as BY16 YHT without spaces. So it has to process this at a meaningful level when it passes it through to the bot framework. And that's just the kind of power. It's a very simple function, but it uses, in a way, fairly complex conversational tactics to do that. But it's not just on phones. We can even look at the way that, pop this forward, people interact with emails. The bot framework can work on an email channel. I've just put a very simple one up there. It's a screenshot, and I realize it might be difficult to see, but you'll hopefully be sent these and you'll be able to see them. And this is just a simple conversation where I'm saying hello to it. I say hello to the bot framework, and it determines based on the channel that's coming in, it knows that I am Joe Tompkinson. So it replies, "Hey Joe Tompkinson, help me tailor my response. Could I ask whereabouts you're from?" I respond with my location, which is fine. And then it builds up, again, another adaptive card, a dynamic, rich response that introduces me personally to the bot framework. And it's about engaging with users on a more conversational level in some respects to make it more streamlined, an easier process, less frustrating. And that's something that these services are designed to do. I'm just going to pop out of this and hopefully show you a couple of demos for this. So the way that Louis works is on a series of intents and entities. Now this is just our demo bot framework that we use every now and then. And I'm just going to explain a little bit how natural language processing works with Louis, just so you can sort of get a better understanding of how it might fit in or be used with your own potential use cases. So the first thing that we do is we create a series of intents. Now these are essentially things that we want our user to be able to do. Are they trying to book something? Are they trying to talk to me about an apprenticeship? Are they wanting to say hello or greet me or be jovial? Are they wanting to get some contact from us? And these intents are then populated with, if we look at the greeting one, utterances. So what these utterances are essentially are a series of things or phrases that would relate to that intent. So a greeting intent, for example, might start off with them saying who they are. Hello there, name of, good morning, good afternoon, or hi, I'm Joe, hi, I'm Sam, etc., etc. And it's important that Louis is trained to understand those, so that it knows that if a structure comes in that kind of pattern, that it needs to be the greeting intent. And what we do in the bot framework is then we run it through a greeting dialogue, because we know that's their intention. And that works the same way if they're asking about apprenticeships at Visual, or if they're wanting to request contact from our inquiries department, or if they want to try out language translation through our bot, or if they simply just want to have a play around with sentiment analytics provided by the bot. And that's leveraged by entities. These are singular sort of objects that represent something. So a person's name, for example, or a location for geography. We have, in this instance, original topics that talks about the various things that we offer as a business. Punctuated words are in there. They are a bit of a weird thing, punctuated words. Anything with an apostrophe is if anyone ever does any natural processing in the future knows, is kind of the enemy of it. But these are very important because they build that whole process out. And then we start to use both. And we go, brilliant, we've got our intents, we've got our entities. Well, let's build up some common patterns, ways in which we could expect people to respond and how I can pick out entities from a phrase. And that drives the natural language understanding process and how this cognitive service essentially tells the bot framework what it wants to respond to the user with. And it's incredibly powerful. It's incredibly useful, and it can certainly leverage a lot of these services for real business case use. Now, if we test this, for example, and I've been doing it a bit when I've been looking around punctuation to try and split these out, but if we just say something along the lines of this test, hello, I am Joe from Stoke, for example. And what that does here is it picks out a series of entities. Now, when you're training this sort of thing, you're going to do this and you're going to look at kind of sentences and phrases, and you're going to ensure that it is in fact bringing back the correct intents and entities. And you can see down there that it's picked out words that can form parts of punctuation. So I am. It's picked out my name, Joe. It's picked out the geography, Stoke-on-Trent, or Stoke for short. So these are things that we can do as developers to draw those entities out and actually do something meaningful with them, so we can respond to the user in a really meaningful way. From a training point of view, this is brought back an intent of none, which is fine, but we don't want it to be an intent of none. So we actually want that to be a greeting. So we might select greeting and we might just retrain it. And what we'll see is the next time it reruns this utterance, it'll score this as a greeting intent. And that's how powerful it is. The training is really quite simple, and you can see now that it's rescored it about 0.8 as a greeting intent. So we can then use that to do something meaningful with it. If we take a quick look at, and this is the live view of that demo, when people interact with it, the first thing that it does is, again, submit a dynamic adaptive card, so you can get an overview, a brief description of how of what you've connected to, and then you can start this process. So I can say hello, for example, and what it's going to say is, hello there, what's your name? And I can say, well, my name is Joe, for example. Oh, sorry. And it's going to say, hi, Joe, because it's picked out my name from that sentence, and it's going to carry on with that dialogue. So it's extremely powerful. It can be conversational. It doesn't need you to be really simple with it. It can handle complex responses if it needs to, and that's what's really important about it. And it's certainly something that most businesses should go away and think about how this fits into their own use cases, both internally and externally, because it's a very exciting time to develop this kind of work. It's readily available to be consumed right now. And that ends my part of this demonstration. So I'll pass you back to Jack.
Perfect. Yeah. Well, thank you for that, Joe. I guess I now open up for a quick Q&A. If feel free to either speak or pop questions into the window, and we can start getting answering them. Then, if there are any, just give you a couple of minutes.